Hey, how you guys doing? These are gonna get really old after a while. Just kidding. I love math. So this is 2003 free response question number 6. I know I'm gonna be in and out of the screen a little bit, or half face, and I'm sorry. Focus the best you can, and again, pay attention. Make sure you understand why the answers are what they are, and should be good. So, anyways, question 6, part A says, is f continuous? Now we have two parts of a piecewise function. That's going to get in my way. Anyways, so one part's used from 0 to 3. I don't really know what it looks like, so let's put a 3 here. It's a square root graph going-ish like this. And then this one is a line, and it goes like this. And the question is it continuous? So either they meet here or they don't. Either continuous, not, I know that's limit, no limit. But if there is a limit, if there was a limit, because one of them has an equal sign here, if you have a limit and then there's an ordered pair here, it's now continuous. So, quick reminder of basic rules. So, to prove something is continuous, you first have to prove there's a limit. If there's going to be a limit at 3, then the limit as x approaches 3 from the left has to be equal to the limit as x approaches 3 to the right. Now this is done easily by just simply plugging a 3 into both of these and making sure they're equal. Okay? But show stuff like this. For your response questions, they give points. Oh, they understand it's a left and a right-hand limit. If you don't talk about the words left and right-hand limits, you won't get all the points for your work. So 3, 0 to 3, that's coming from the left-hand side. So this is from the left-hand side. So if I put a 3 there, I get a 2. And again, I can even use the words left and limit. They love this stuff. And I'm going to plug in from the right-hand side. From 3 to 5 is this line. So I'm going to plug a 3 into this one. 5 minus 3. And again, the question mark is, are they equal? And of course, you get 2 here. And that is your right-hand limit. And of course, they are equal. So the left-hand limit equals the right-hand limit. Therefore, there's a limit. The limit as x approaches 3 of f of x, that limit is 2. So there's a limit. Now remember, a limit doesn't mean it's continuous. That's a limit. Limits are weak. To prove it's continuous, you have to prove there's an ordered pair there. But that's done easily enough. If I were to plug in a 3, I want to know which one do I plug the ordered pair into. Because of the equal sign, I'd plug a 3 into here. And basically, all I need to say is it's equal to the ordered pair. F of 3 also gives us 2. Alright? So then you just put the answer, yes, continuous. If these two are not equal, you'd say not continuous, move on to the next part. Alright. The next question says, find the average value of f of x on the closed interval from 0 to 5. Now, first of all, average value of a function is no longer on the AP exam. However, a lot of the steps leading up to our final answer are important. So let's talk about average value. The average value formula is the 1 over b minus a integral from a to b f of x dx. So it's 1 over, and they want it on the interval 0 to 5. So 1 over, right, 0 to 5, 0 to 5. So 1 over 5 minus 0, integral 0 to 5, f of x. So basically, it's going to be 1/5 of the area. Okay? Now, it's 1/5 of the area, but something you have to keep in mind here is we're not going to have the average value part in front. Gosh, this is going to be great. But we are going to have to do things like this, like find the area underneath the curve. So when I want to find the area underneath the curve, I'm finding the area underneath this graph from 0 to 3, and I'm finding the area from 3 to 5 underneath this graph. So I'm going to save the 1/5 at the end. At the very end, I'll bring the 1/5 back. But for the time being, we have the integral from 0 to 3 in the area underneath this. And I'm going to call this x plus 1 to the 1/2 power. And then the area underneath this from 3 to 5. Okay, but I don't want to mess with this right now, so I'm just going to move this off to the side. I'm just going to deal with this part. Okay? Now, this right here is simply, imagine this was a u substitution. If the u was x plus 1, the du would be 1 dx. We have a 1 dx. So really you could think of this as u to the 1/2. And again, we'd already have the exact thing we needed for the du. So it's the antiderivative, add 1 to the exponent, multiply by the reciprocal, no plus c, and then we would replace. So we have 2/3 u to the 3/2, and we put an x plus 1 here, and my numbers going in are 0 and 3. So I plug in a 3 and a 0 and subtract. When I put a 3 in here, 3 plus 1, obviously that's going to be a 4, minus. And I put a 0 in here, 0 plus 1, obviously it's going to be a 1. So I'm going to change this now to a 4. And I'm going to change this to a 1. Now let's deal with 4 to the 3/2 power. 4 to the 3/2 power, I am going to do it in this order. I'm going to square root first and then bring it to the 3rd power. So that's 2. 2 to the 3rd power is 8. So here I get 2/3 of 8 minus 2/3 of, and 1 to any power is 1. Remember, this is free response. This is earn it stuff. I don't need to simplify that. Could I? Yeah, 16 over 3 minus 2 over 3 is 14 over 3. But that's how I choose to write 14 over 3. And it looks like your AP exam is going to be free response, meaning a lot of earn it. I don't know exactly how the free response are going to look yet. I'll find more out later. But earn it is better than earn it. So let them do the work. This looks good, and that's almost off the screen. That might even be below the screen. You might not even be able to see that. Well, it's perfect, because it doesn't exist. Okay, let's go to the second part of this. Remember, we needed to find the second area from 3 to 5. So plus 5 minus x from 3 to 5. And the antiderivative of this is 5x, and the antiderivative is here, add 1 to the exponent, multiplied by the reciprocal. And again, a whole pile of earn it. I plug in the top and the bottom and subtract. So I'm going to plug in the top, a 5. Minus, and now I'm plugging a 3. I'm not simplifying any of this, but this better be in parentheses. If this is not in parentheses, this minus, remember you plug in the top and the bottom and then subtract. The minus sign must belong to all this. If you don't have parentheses, you're wrong. Something interesting I just realized, I could have left this. I didn't even need to simplify one step further, but that's okay. So this is my answer. This is my area. But remember, we need a 1/5 in front. So I'm just going to use a big set O brackets, put a 1/5 in front. There you go. If you want to simplify that, you can, but that is how I choose to write the answer. 4/3, that's 4/3. Oops. Yeah, 4/3, it's beautiful. All right, anyways, let's go to part C. Part C asks you to look at a function g and find out what are the values of k and m that make g of x differentiable. So I'm going to erase. If erasing is boring for you, you're welcome to hit the fast forward button. I'm getting paid to erase though. Just like to point that out. Okay, so let's go ahead and write down what is g of x. We'll use it in blue, so if you're fast forwarding, you'll be like, oh, it's blue. And that'll be fancy. All right, they want us to find the values of k and m to make this thing differentiable. Now, differentiable is a loaded word. Differentiable means it has to also be continuous. It must be continuous if it's going to be differentiable. So if this is going to be differentiable, it first must be continuous, meaning these two have to be equal. This, that's a fail, has to equal this, specifically where they meet at 3. So I'm going to replace the x's with 3's. If I put a 3 there, 3 plus 1 is 4, square root of 4 is 2. So I get 2k, put a 3 there, I get 3m plus 2. So if it's going to be continuous, these two have to be equal, and I'm looking at this problem realizing I can't solve it. So since I can't solve this, I'm going to go on to the second part. So this is continuous, but to be differentiable, it has to be continuous and differentiable. That's the continuous part. The differential part, we'll have to look at the derivative. Now, to look at the derivative, I'm going to make this to the 1/2 power. And I'm going to bring the 1/2 to the front. And then the exponent goes down by 1 times chain. The chain is a 1. I'm not going to write it. And the second part, the derivative of mx, is simply m. So I need these two to be equal when I plug in 3. By the way, I'm going to rewrite this. The 1, I got the 2, the k is up here, but I'm going to drop this to the bottom and make it a square root. Nice. So this part can be written like this, and the second part of the piecewise function is here, and we want these two to be equal when we plug in a 3. So we want k over 2 of x plus 1 to equal m when x is 3. I'm going to put a 3 there right now. That's 4, square root of 4 is 2, 2 times 2 is 4, and I get k over 4 equals m. I can't do anything with this as well. So I got this. If it's going to be differentiable, this continues. Well, differentiable means this and this. I can't do anything with this. I can't do anything with this, but I can use substitution. I'm going to get k by itself since k is all nice over here. So I'm going to multiply that 4 to the other side and plug it in right there. So I now have 8m equals 3m plus 2. My board is getting very wiggly. I'll have to fix that. Anyways, I'm going to multiply it to the other side. That is 5m equals 2, and I'm going to divide. M is 2 over 5. Once I know m is 2 over 5, I'm going to plug it back in right there. I could have plugged it other places. And 2 over 5, and we get k is 8 over 5. And done. There's your k, there's your m. Let me check online. Touchdown, we did it. Great, hope you enjoyed the video. And again, each and every day, you're going to have 4 of these. Try them on your own, grade them, and then look and see how I did things to see where you messed up and how you can improve. Keep working hard every day. Care about you guys, and I hope you're staying safe, and make sure to wash your hands. And remember, my class is the most important. Goodbye.